Good afternoon, everyone. Sri Lanka is known for rich diversity of fish in its aquatic ecosystems. Among that, this endemic fish introduced in 2018 was taken most of our attraction. This fish was known as LABEO heladiva, and it was the main focus of my research, and it was titled as Evaluation of Induced Breeding Potential of LABEO heladiva. I'm Bandara. Let's dive through this presentation through these main topics. LABEO heladiva, colloquially Hirigania or Sri Lankan LABEO, was belongs to family Cyprinidae. Before 2018, it was known as LABEO dusumeni. Morphologically, LABEO heladiva has elongated body with dorsally greenish grey color and whitish ventral side. Laterally, it has pinkish orange color markings and black color patch on its caudal peduncle, and specifically, it has two pairs of barbels. From previous, it was considered as a minor cyprinid species in inland fishery sector. Even if it is not a major target for fishermen, without catch restriction, it has a possible threat of overexploitation. That's why there is a need of study on their aquaculture potential. But there was no literature available regarding the breeding under captivity. Based on that, this research was aimed to assess the feasibility of captive breeding of LABEO heladiva, specifically to investigate the effect of different ovulation doses on its induced spawning, and to examine the embryonic development. These objectives were implemented by getting permission from Ethical Review Committee of Faculty of Applied Sciences and Department of Wildlife Conservation. The fish were collected from Sundarabarathy was carefully transported to the study site Aquaculture Development Center in W. At the center, fish were acclimatized for 1 month time period in cement tank for male and female separately, which were provided with these water quality parameters. Fish were fed with sinking commercial feed pellets and checked for any diseases during that time period. After 1 month, they were mature and healthy fish were collected for breeding experiment. Initially, they were measured for weight and total length, and based on this weight, they were administered with ovulin hormone, which consists of salmon gonadotropin releasing hormone analog and domperidone. The hormone was injected intraperitoneally at the base of the pectoral fin. For the experiment, 3 doses were tested. Female was injected with 0.3, 0.4, and 0.5 milliliter per kilogram of the body weight, and male were injected with constant dose of 0.25 milliliter per kilogram of the body weight. Each treatment were triplicated, and male to female ratio was at 1:1. After injecting hormone, each breeding couple was kept in separate spawning tank, which were provided with constant water flow. After releasing of eggs, sample of eggs were collected and observed under stereo microscope to study their embryonic development. During the whole experimental time period, water quality parameters were checked for pH, temperature, dissolved oxygen, electrical conductivity, ammonia, and water hardness. Collected data was analyzed to find the number of released eggs using weight-based method and hatchability and survival rate based on volumetric method using these equations. These results were analyzed based on Varney, ANOVA, and Turkey's test using Minitab computer software. With that, let's move to the result part. This graph shows the mean. These are the water quality parameters continued during the breeding experiment, and here the pH, dissolved oxygen, and temperature was at the optimum range of the fish. And this graph shows the mean number of released eggs for the breeding experiment. Here, this treatment shows the significantly different from each other, and the highest number of released eggs were given when female was injected with 0.5 milliliter per kilogram of the body weight. And this graph shows the hatchability and survival of the post larvae, and this treatment was not significantly different from each other. and these pictures show the stages of the embryonic development. You can see the stages from formation of the blastoids to head and tail differentiation, and after hatching of eggs, the larvae develop into post larvae by reducing the yolk sac step by step. With that, I would like to conclude the results. Induced spawning of the LABEO heladiva was successfully achieved using ovarian hormone using all 3 tested doses, but highest spawning could be achieved using female were injected with 0.5 milliliter per kilogram of the hormone. After 9 to 10 hours of latency period, eggs were hatched at 28 hours, and larvae were reduced their yolk sac after 75 hours. Based on this result, aquaculture farmers can be recommended to use ovarian hormone to induce breeding of the LABEO heladiva using these hormone doses for males and females. With that, LABEO heladiva is an endemic fish with great potential for aquaculture, and protecting it can also support the sustainable fish farms. These are the references I use for this research, and thank you very much for all who support this research, and thank you very much for your attention and this opportunity.